Hello, everyone, and welcome to today's class on time value of money and its application. Now, if we think of the world of finance, one of the key concepts is time value of money. And this is very important from the aspect of this particular course. And we will learn exactly why in just a minute. So this slide is not a new slide. Right in the beginning of this course, I mentioned to you that in financial management, we will be learning how to increase the value of a firm. And in order to really understand that, we will need to calculate the value of the firm. And to calculate the value of the firm, we need to learn certain key principles, fundamental principles of finance. And the first one is the time value of money. Later on, we will also be looking into financial statements. So if we want to look at this pictorially, this is what we will be learning in the future, right? So we will be calculating the value of a firm. And in order to do that, what we will be doing is we will be calculating something known as free cash flows. And we will be sort of discounting the free cash flows to time zero to understand the value of the company. Now, the discount rate at which we are going to be discounting the free cash flows at is going to be known as something called WACC, or weighted average cost of capital. And we will also learn a lot about this and how it can be calculated. So there's a lot of exciting things in the future, but in order to be able to, excuse me, calculate the value, you do need to know how to calculate or discount the free cash flows. And so that's where the whole time value of money comes in. And that's why it's important for you to be very, very comfortable with concepts such as present value, future value, annuities, things along those lines. And so the object of this particular class or this lecture is to really familiarize you with all the key concepts so that you are extremely clear. So one of the main things in when you are dealing with the time value of money is to always make something known as a timeline. And here you can see this is an example of a timeline. And so this is the first step whenever you're dealing with anything that requires you to sort of, discount or compound anything. That's what you need to do. You need to sort of draw a diagram. And in the diagram, you will be sort of identifying what is happening, and then you can easily start solving. But before you solve, it's important to put it on a timeline. And here, as you can see, it says, on the top is the period. So it's 0, 1, 2, 3. And so this could be, time zero, and then first year, second year, third year. There's certain words such as, PV, which stands for present value. So that's 100. And so they're saying in this, just by looking at this, I can say, what's going on over here is that somebody has cash worth of $100 at time zero. And they are trying to figure out what the future value will be of this money if they deposit it or let's say invest it somewhere for 3 years at 5%. So maybe somebody's thinking of putting their $100 in a bank that's going to be giving 5% year on year. So, and they want to know exactly how much this $100 is going to be worth at the end of 3 years. Now, in general, if there is an inflow or you're putting money in, then that is shown as a positive amount. But if money is going out, then that is shown as a negative amount on a timeline. Now, on this slide, I kind of wanted to just sort of familiarize you with a lot of terminology that is going to be used in time value of money. So the first one is PV, and this means the present value. And so in the example that we just discussed, The present value at time 0 was $100. And then the next one is future value. And here, right here, you can see this N, this small little N over here. And so this is basically a number of periods. So this is the future value in after N periods of time. And so this is just another terminology. CF stands for cash flows. This can be positive or negative, as I just mentioned in the last example. If cash is coming in, it's positive. If it's going out, then it is negative. And so this is very important for you to remember. Generally speaking, cash flows, you get the cash flow at the end of the period. Let's say it's a 3-year, you've invested your money for 3 years in a bank. Well, you are going to get your money back at the end of 3 years. However, in some situations, you can get the money at the beginning of the period. So you may be getting the money at the beginning of period of the 3rd year. It really depends. And generally speaking, it's always at the end unless it is specified otherwise. I stands for interest earned per year. So this is, if it's like in the last example, it was 5%. That means that every year, you will be earning 5%. So if, for example, you invest $100 for 1 year at 5%, then at the end of the 1 year, you will get $5 as interest income. Okay, so in this situation, it is, always annual when it's put on a timeline. And if, let's say, there is a situation in the future, in the next few slides down, I'll be talking about, there are certain times when interest is compounded semi-annually or quarterly or monthly. Well, in that case, you can also annualize it and put the annualized interest rate on the timeline. Okay. INT stands for the dollars of interest earned during the year. So like I just mentioned, the $5 that you would be earning if you're investing $100 and you're earning 5%, the $5 we will get at the end of the year is going to be your interest income. So that is, INT, and 5% is going to be I. So the actual in dollar terms, it's going to be referred as INT, but in percentage terms, it will just be I. And N is the number of periods involved in the analysis. So like in the last example, the example was for 3 years. Well, in that case, N will be 3. So in some cases, I just wanted to point out the I over here that can be, it's usually a capital I, but sometimes it can be a small lowercase I. Either ways, it still represents interest. Same with N. It could be a capital N or a small n. Regardless, it would be referring to the number of periods involved in the analysis. All right, so now let's get into the fun things and start learning about how to calculate future value. And so when you are dealing with the time value of money, one of the most important concepts for you to remember is that $1 in hand today is worth more than $1 received in the future. So if I have money today, it is more valuable than if I receive the same amount of money, later on, a year from now. So let's say I have $100 today. That's more valuable than if I get $100 10 years from now. Because obviously, if you think about it, I can use that money today. I have it in my hand. The utility of that money is a lot more than if I get it later on in the future. So one thing as far as future value goes is that when you are moving from a present value to the future, so you're saying, okay, I'm investing money today, and now I want to know what's going to happen in the future. That is an example. That is, you're calculating the future value, and it's also known as something called compounding. So you are compounding to figure out what the future value is. And so here you can see there's a timeline, and you can see it's the same example as the last one. Somebody has invested $100 and at 5%. And so in 1 year's time, they are going to be making 105. And if they leave the money in for a little bit longer, they are going to be making 110 in 2 years' time. And in 3 years' time, they're going to be making 115.73. Now, what if you wanted to calculate the calculate all of this using a formula? So here you can that's going on over here is 100 is being multiplied by 1.05. Then 105 is being multiplied by 1.05 again, and that's going to equal to 110.25. And that is being multiplied by 1.05 again to give you 115.76. Sorry. Now, if you wanted to, however, just sort of use a shortcut approach and use a formula, and given that you had this timeline, just the basic information on the timeline, what you could do is use this formula, which says future value is equal to present value, 1 plus I, which is the interest, and there's the n is the exponent, which is 3. Because n in this case, there are 3 years, so it's going to be 3, and it's 1 plus I is 0.05. So if you just plug it in this formula, you will get right straight away 115.73. So this is a shortcut way of just calculating the future value. If you know the present value, you know the I and you know the n. So this is used very frequently in the time value of money. If you would like to, calculate the future value in a spreadsheet in Excel, that can also be done. And so the way you do it in Excel is you basically press equal, and you just put in FV for future value. And then in brackets, you need to first put in the interest rate, which is going to be 0.05. You have to, next comma, you have to then put in n, which is 3. Then you put in 0. And then you put in negative 100. And that will basically give you 115.76. So this is basically how you can calculate the future value using a spreadsheet. So one thing to remember is also that there is a difference between simple interest versus compound interest. So right now, up till now, everything that I showed you, that was compounding, and that was using compound interest. And what that basically means is that you are going to be earning interest on the interest. So for example, the $100 after 1 year, you had 105. 5 was the interest income. And so then in the next year, you are also going to earn interest on the $5, not only the initial $100, but also the $5. And so you are earning interest on interest. That's one way of doing it, but there is another way to calculate interest, which is that you only calculate interest on the principal amount. You do not calculate interest on interest. Only interest is going to be given on the principal amount. And this is usually done in banks. So banks do not use compounding. They usually use the simple interest formula to calculate the interest. And in this situation, for example, the same example, we have investing $100 for 3 years at 5%. Well, this is how they would calculate the simple interest. It would be, present value of 100 plus present value into I, 0.05 into N, and that would give you a total of 115. And if you recall, in the previous example, it was slightly more when we were using, it was 115.76, I believe, which is more because in the previous example of compounding, because you were earning interest on interest. So this is an important thing to keep in mind. here in this particular slide, I just wanted to show you, you know, what a difference it makes, the interest rates that are being offered by various organizations. So if, for example, you put in your money at a 0%, you're not going to be making very much. You're going to have exactly the same amount in 10 years' time as you had right at the beginning. However, if you're earning 20%, you'll be seeing a significant spike or increase in your investment. If on the other hand, you're getting a negative, you're earning a negative 20%, the value of your money is going to be going down. So it's going to be a lot less. So in period of 10 years, you can see how much it, we've kept the amount of time the same here, 10 years. But the main thing you can see is that interest rates, what kind of return you get based on various. Okay, the next concept that I wanted to talk to you about is something known as opportunity cost. And opportunity cost is the rate of return you could have earned on an alternate investment of similar risk. So let's say there's a broker, he's willing to sell you a bond that is guaranteed to pay you 115.76 in 3 years' time. And on the other hand, banks are also offering you guaranteed 5% interest on 3-year certificate of deposit. And you decide to go to buy the bond instead of the CD or the certificate of deposit. Well, your opportunity cost is going to be the certificate of deposit. So you could have invested your money in the certificate of deposit. It had similar risk and return, but you chose to go for the bond. So the certificate of deposit will be your opportunity cost of your investment. Okay, next I'm now going to move towards calculation of present values. And when you are calculating present values, remember when we were calculating future values, that was also referred to as compounding. When you are calculating present values, that is also referred to as discounting. And discounting is the reverse of compounding, okay? So just like there was the formula that I showed you for compounding, which was for future values equal to present value 1 plus I to the power n. Discounting has another formula, which is present value is equal to future value divided by 1 plus I to the power of n. So here you can see, it is a reverse kind of a situation going on. Now, similar to calculating future values in a spreadsheet, present value can also be calculated in an Excel sheet. And if you would like to calculate the present value in an Excel sheet, well, this is exactly how you would input it into your Excel sheet. You would say equal to present value, and then you would add the interest rate, 0.05, 3, you would add a 0, and you would say that you would know the future value, which is 115.76, and you would press enter, and that would give you 100. So here, this is the same example, but the only difference is that when you're calculating the present value, you are given the future value, and using that, you are asked to calculate the present value. So yes, so you can see both the formulas for present value and future value. And by the end, yeah, we've given you a lot of practice problems, but you should be very comfortable with these concepts. And the way to get comfortable is to do a lot of practice. And so, right, like I had mentioned at the beginning of this lecture, you will be using present value to calculate the value of firms. So remember when I was telling you how you had to discount the future cash flows at the rate of the weighted average capital WACC, or the weighted average cost of capital. Well, that whole thing that involves finding the present value, right? So present value is something you will be using to really calculate the firm's value and understanding how to further maximize the firm's value. And as I had mentioned, this is one of the goals of financial management. Now in this slide, you can see it looks pretty much the opposite of the future value slide that we had seen. And so here you can see a reverse situation happening. Obviously, if you're investing at 0%, the amount $100 at 0% in the future or present value is just going to be zero. And then here you can, graphically sort of see the impact that interest rates have on present value. Yep. You can see if the interest rate is high, very high, the present value is going to be lower versus if the interest rate is low, the present value is going to be higher. Now, in certain situations, what happens is that the present value is going to be given to you, the future value is going to be given to you, the number of years is going to be given to you, but the question may ask you to calculate the interest rate. And the way to do that, there are two options for you to calculate the interest rate. The first one is on the left, right over here. You can just plug away into the formula, which is future value is equal to present value 1 plus I to the power n. And when you plug it in, this is what your formula, what it's going to look like. 100, 1 plus I to the power 10 is equal to 150. Here you divide 150 by 100, that is going to give you 1.5. And then in order, because this is equal to 10, what you can do is take both sides to the power of 1 over 10. And that is going to give you 1 plus I is equal to 1.0414, which when you subtract 1 from that, that is going to give you 0.0414 or 4.14%. You can also go into Excel and use the rate function. And if you decide to do that, the formula for that is we're going to go into Excel and say equal to rate brackets n, which is 10. In this situation, payment is, there is no payment being made of any sort. So that's why it's 0. The present value is going to be minus 100. And that's just the way it's put in Excel. And future value is 150. So that is going to give you, again, the same solution, 4.14%. In some other kinds of problems, you may be given all the information. So the future value, the present value, the interest rate, but you may not be given n, or the number of periods. So how would you calculate that? And let's look at an example. So this example says we now have 500,000 and the interest rate is 4.5%. How long will it take before we have $1 million? So here, this is 1 million is the future value. 500,000 is the present value. So we're just plugging it in. Future value is equal to present value 1 plus I to the power n. So future value of 1 million is equal to 500,000 brackets 1 plus 0.045 to the power n. And if we divide this, so 1 million divided by 500,000, that is going to give you 2 is equal to 1.045 to the power n. Basically you take the natural log on both sides, and that is going to give you 15.7473. There is an alternative. You can use the n per function in Excel. And if you put that in, it is going to be equal to NPER brackets, put in the interest rate. There's no payment, so that's 0. And so the present value is always given as a negative in Excel. So you say negative 500,000, and then you say the future value, which is 1 million, and close the brackets, and that will give you 15.7473, which is exactly the same as you got by calculating it by hand. Next, I want to talk to you about something known as a perpetuity. And a perpetuity basically means an annuity or an amount of money periodically that is going to be given forever, forever. So that would be a good situation, right? So you are forever being given a certain amount of money. And so because it's forever, that's a little bit complicated to, you can't to solve, right? So if you wanted to solve, find the present value, how are you supposed to do that? Because you don't know n is like in an infinite amount. So the formula to calculate a perpetuity is payment divided by I. So whatever amount that you're getting on a regular basis, that is going to be the payment, and you divide it by the interest rate. And so if it's the interest rate is 7%, you would say whatever the amount of money you're getting, let's say it's $1,000. So $1,000 divided by 0.07. So you always want to make sure that you don't never put in 7%. You always want to sort of put in decimal points. And so that will give you the present value of a perpetuity. That's how you calculate the present value of a perpetuity. Okay, next I want to talk to you about something known as annuities. And annuities are payments that are equal and are made at fixed intervals. So regularly you are going to be either making a payment regularly at every, let's say it could be every month or every 6 months, whatever the amount of fixed intervals. So for example, you could be asked that to pay 100 is paid at the end of each of the next 3 years. And so that is going to be a 3-year annuity. Again, 100 is paid at the end of each of the next 3 years. And that is going to be a 3-year annuity. If payments occur at the end of each period, then we have an ordinary annuity. However, and this is an ordinary annuity is also known as a deferred annuity. However, annuities can also be paid at the beginning of every period. And if they are paid at the beginning of every period, that is known as an annuity due, which is different from an ordinary annuity. And so this is just, these are two annuities shown on a timeline just to familiarize you with them. And the first one is an ordinary annuity. And here you're seeing that you're having to make, somebody's having to make payments of $100 every year for 3 years at 5%. 5% is the interest rate. And in an annuity due, they have to pay at the beginning of the period. So here you see all of a sudden it's, minus 100 at times 0, 1, and 2. Again, the interest rate is the same. So everything is the same in both of these examples. The only difference is one is an ordinary annuity and the other one is an annuity due. Now, if you need to calculate the future value of an ordinary annuity, then this is basically how you would do it. You could basically take the payment of 100 and you are basically going to be compounding it for 2 years, for 1 year, and for 0 years, because you'll be getting the 100 at the end of the year. So that's why the last one is 0. And so that will give you a total of 315.25. Alternatively, you can also use a formula. This is the formula to calculate the future value of an ordinary annuity. And this is just equal to the payment, brackets 1 plus I to the power n minus 1 divided by I. You can also calculate this same future value of ordinary equity using, or an annuity using Excel. And the formula for that is going to be equal to, here you would say equal to future value brackets 0.05 comma 3, which is n. The payment is minus 100. That is an outflow, and the present value is 0. And that will also give you the same amount of 315.25. Now, if you want to calculate the future value of an annuity due instead of an ordinary annuity, all you would do is, after you calculate the future value of an ordinary annuity, you would just multiply it by 1 plus I, which is in this case 1.05, and that will give you 331.01. In Excel, if you want to calculate the future value of an annuity due, the main difference is instead of a 0, you would put a 1 right over here, and that would automatically give you 331.01, same amount that you just calculated by hand. If you would like to calculate, on the other hand, the present value of an ordinary annuity, you can use this formula on the slide. And here again, it's just, very easy. You just plug in the information that was given in the example. We knew that the interest rate was 5%, and we know that the payment is 100, and that would give you 272.32. Again, for a lot of these, I firmly believe, actually doing it and solving problems is what really familiarizes you and gets you comfortable with these concepts. You can calculate an ordinary annuity using a spreadsheet. And for that, the function is going to be equal to present value, interest rate, comma, the number of periods, comma, the payment, which is going to be a negative amount, negative 100 over here, comma, future value, which is going to be 0 because you are calculating an ordinary annuity. And that will give you the same amount, 272.32. Now, if you wanted to calculate, on the other hand, the present value of an annuity due, this can be calculated by finding the present value of an ordinary annuity, and you multiply it by 1 plus I. In this case, you'll be multiplying it by 1.05, which would give you 285.94. If you wanted in Excel, you would use the same formula as you would for an ordinary annuity, except here in the type, you would put in 1 if it's an annuity due instead of 0. Now, in some situations, you need to find the number of periods n for an annuity. So you may not be given the periods of n. That's something that maybe the question asks you. And if that is a situation that you are asked in any question, find the number of periods for an annuity. Well, you can use the n per function in Excel. And this is exactly how you would enter it: n per brackets I, interest rate, payment, present value, future value, and type. And if it's you may already know that if it's an ordinary annuity, it would be left at 0. If it is an annuity due, it would be a 1. So that is how you would calculate the number of periods for an annuity. Now, up till now in this lecture, we've been seeing regular cash flows, but sometimes in a timeline, if we make a timeline, for example, there are certain financial decisions that involve irregular cash flows. And what irregular cash flows means is that, let's say you have a timeline of 3 years, the amount of, let's say, cash inflows or outflows are not the same year to year. Now, generally speaking, there are 2 categories of uneven cash flows. The first one is that of an annuity. And in an annuity, and just for reference sake, on the slide on the left-hand side, you can see what's happening in an annuity. So here in an annuity, you are getting regularly, $100, right? But at the end, you're getting 1,100 because you're getting your principal amount back in the 5th year. So that's why this is, an uneven cash flow. So that's one example, right, of an annuity. Where you get a lump sum at the end. And so that's why it's an uneven cash flow. And otherwise, there can be, irregular cash flow streams year on year. And so here on this slide, on the right-hand side, you can see an example of an irregular cash flow stream. So in year 0, you're getting 0, but in the first year, you're getting $100, second year, 300, third year, you're getting 300 again. fourth year 300, but in the fifth year it jumps up to 500. And so it's important to know that when you're figuring out, present value or future value, sometimes you will be faced with dealing with irregular cash flow streams. Now, let's say you have to find the present value of uneven cash flows. How are you going to do it? Well, one of the ways is that you discount each one of the cash flows, and you add up the total amount. So right here on the top, you see that in a formula form where you have I is going to stay constant, that is the interest rate, N is the number of periods. And so, it's the summation of all the discounted cash flows that is going to give you the present value of uneven cash flows. If you would like to use Excel to figure out the present value of uneven cash flows, you can use the functionality in Excel, and the functionality to be using is going to be right here on this. You can see it right over here. It is going to be you have to press equal to, which indicates in Excel that you're about to put in a function, NPV brackets I, and I stands for the interest rate, and then bracket and then comma cash flows. And here you basically add all the cash flows. Like we saw in the last example, there were some uneven cash flows. So here you would say equal to NPV bracket 0.12, comma 100, comma 300, comma 300, comma 300, and then 500, and you close the bracket and press enter, and that will give you 1016.35. So this is how you would be able to calculate the present value of uneven cash flows in Excel. Now, next, I'm going to talk to you about another situation. And here you are going to be told that in this example, let's read out the example and I'll explain how you can solve this question. This question particularly involves the future value of uneven cash flows. So we just saw how to figure out the present value of uneven cash flows. Now I'm going to tell you about how to figure out the future value of uneven cash flows. So let me read out an example to you of a question just to illustrate this. So the question is, now suppose you can save only $1,200 annually, but you still need to have a total of $10,000 in 5 years. What rate of return would you have to earn to reach your goal? So here they're telling you that, look, every year you are going to be investing $1,200 annually. You know that by the end of 5 years, you want $10,000. So the question is, what should the interest rate that the bank is giving you, what should it be offering you so that you can, these $1,200 that you're putting in annually can accumulate to a total of $10,000 in 5 years? Well, in order to solve this, if you wanted to do it manually, you would have to put in different interest rates and sort of do a little bit of trial and error. But in Excel, there is a functionality known as the rate function. So in Excel, you can basically, if you wanted to solve this question, you would go into Excel and press equal to rate brackets N, which is the number of years, comma, the payment. And because you are paying something, this is an outflow, it would be negative 1,200, comma, present value, which is 0. And then future value, is 10,000 and close bracket. And the answer will be, in this case, 0.2578 or 25.78%. So here you can see, when dealing with uneven cash flows, how you can calculate different variations using functionalities. Now, the last question was slightly tricky because, you were given certain variables, but you didn't know what the interest rate was. So you use that functionality to figure it out. But sometimes if you just are asked to just plain simple find the value of the future value of an uneven cash flow. Well, in this case, you will be compounding each one of these individual cash flows and then adding the cash flows once they have been compounded. And the formula for this, here you can see right at the top, this is the formula for compounding. N, as you know, stands for the number of periods, I is the interest rate. And so you can just literally plug in your cash flows and the interest rate and the number of periods, into this formula, and you can then, sort of add each of the individual cash flows, each of the individual future value of the uneven cash flows, and that will give you the total future value of the uneven cash flows that you are calculating. Now, similarly, if you wanted to go in and actually calculate the future value of uneven cash flows using Excel, there is a functionality, and in this case, it's actually a two-step process. So first, you would need to calculate the present value. And I just explained how you would calculate the present value of uneven cash flows. So you would calculate that. And then in order to calculate the future value of uneven cash flows, you would sort of input the future value brackets, the interest rate, and then you would add the number of periods, and then it would be 0, and then minus, you would add the present value. So that would be a negative, and you have to add a negative value in front of it. So again, it's basically you are using various functionalities in Excel to be able to calculate uneven cash flows. So again, you could calculate the present value of uneven cash flows and the future value of uneven cash flows in Excel. Okay, so just a couple of slides ago, I kind of spoke to you about a situation, figuring out, what the interest rate was when there were various payments being made, and those payments were the same every year. And you wanted it to, you knew what you wanted at the end of 5 years, and you knew that, yearly you would be putting in $1,200, and you had to figure out the interest rate. But let's say I'm giving you another scenario. And in this scenario, you know what the present value is, and you know that there are certain irregular cash flows, and you are being asked to calculate what is the interest rate. In that situation, if you know what the present value is, and you are given a set of irregular cash flows and asked to find what the interest rate is, then in that case, you would use a functionality in Excel by the name of IRR. And this stands for internal rate of return, just for your information. And here, this is the way you would solve for it would be, you would basically take all of the cash flows, including, the cash outflow right in the beginning, and all the inflows. Right? So let's say you invested, in this example, you invested $1,000 in a bank, and then you are going to be getting some sort of an interest rate or interest income every year. In this case, you will get, in the first year, you'll be getting $100, second year, $300, third year, $300, fourth year, $300, and fifth year, $500. And let's say you wanted to find out, what is your, the interest rate that you are earning based on this particular transaction, or, what is the internal rate of return? Well, you can do that by putting in the functionality IRR in Excel. And here you would basically, it would be that you would press equal to IRR bracket, the first negative cash flow, 1,000, comma 100, comma 300, 300, 300, 500, close the bracket and enter. And another way of sort of, instead of actually writing each cash flow and putting in a comma after it, what you can also do is just sort of go, in this situation, the first outflow cash flow is B 546 right over here. So you say B 546 and then a semicolon, which basically means start from B 46, but please take into account all the cells all the way until G546, and you close brackets, and that will give you 12.55%. So that's how you would calculate internal rate of return or the interest rate with irregular cash flows. Now, so far we have been discussing interest rates, but in every situation we've just been, sort of talking about a yearly interest rate. So if it's, let's say 6%, that means that that is the annual interest rate, but that is not always the case. There are certain situations where the number of compounding periods per year is different. For example, you could have an interest rate that is being compounded twice a year. So that would be a semi-annual compounding. It could be that you have quarterly compounding, which means that your amount of money, the interest rate is being compounded 4 times a year. So M in general, the letter M, this refers to the frequency of compounding. There are different types of interest rates. The first one is a nominal annual interest rate that is also represented as INOM. Another word for that, a nominal rate on loans is called annual percentage rate. Next, I will also be talking to you in the next couple of slides about periodic rates and also about effective annual rates, or EAR. So it's important for you to be familiar with each one of these. And again, nominal rate, the annual nominal rate, that is just the normal annual interest rate that we are talking about, right? And also, if you hear the word annual percentage rate, well, you should know that that is basically the nominal rate on a loan. So it's again an annual rate, unless specifically mentioned otherwise. Now, in some situations, you will have to calculate the periodic interest rate, and you generally will have to calculate the periodic interest rate if there is some sort of compounding other than annual compounding. So if there is semi-annual compounding, quarterly compounding, monthly compounding, for example, then in that case, you will have to use something known as the periodic rate. And the periodic rate is basically going to be the nominal interest rate divided by M. So M is the number of periods that it's being compounded. So for example, if it's semi-annual, that means the interest rate is being compounded twice a year. So M will be equal to 2. If it is a quarterly compounding, then M is going to be equal to 4. So that's how it works. And if it's a monthly compounding, then M is going to be equal to 12. And generally, if you are, solving a question that has some sort of periodic compounding, then you will want to put the periodic rate on the timeline. And that is also going to be the rate that you are going to be using in all of your calculations if there is some sort of, compounding other than annual compounding happening in any question. Okay, so now let's actually go ahead and solve a question that involves semi-annual compounding. Okay, so let me read out the question, and then we will look at how it's reflected on a timeline, and then we will figure out how to solve it. So in this, the question says, suppose you invest $100 in an account that pays a nominal rate of 12% compounded quarterly, or 3% per period. How much would you have after 2 years? Okay, so in this particular situation, we are being told that it is being compounded quarterly. That means 4 times a year, the interest rate is being compounded for 2 years. So that's why if you have to make a timeline, M is going to be 8, because you are going to have 4 quarters in a year multiplied by 2 years. That means there are going to be 8 periods. in which the compounding is going to be happening. And here on the timeline, you can see that at time 0, there's an investment being made into an account of 100. So that's why it's minus 100. And now if you have to calculate the future value, because that's what the question is asking you. You're investing $100 today. The interest rate is, 3%. And the way you calculate 3% is you have 12%. And, since it is being divided 4 times a year, so you take 12% divided by 4, and that gives you 3%. So you know that your I norm is going to be, you have to, the periodic interest rate is going to be 3%. Okay, so how are you going to figure this out? Well, you put it in the formula right over here. The future says future value is equal to present value brackets 1 plus the periodic interest rate, which is 3%, into to the power of the number of periods. Now here, because we just saw the number of periods in this question is 8. The number of periods is not 2, it is in fact 8. And the reason it is 8 is because we have taken 2, which is n, and we've multiplied it by m, and m is 4, right? So because that's 4 times it's being compounded. So that is how you would solve it. And right over here, if we really just wanted to put it all in a formula, it would be this right over here. Present value brackets 1 plus nominal interest rate divided by m to the power of m into n. And here, if we plug it all in, we would be getting 126.68. And so 126.68 is what the future value is going to be in this question. Okay, well, now I want to talk to you about something quite interesting, which is the effective annual rate. Now, let's say there are 5 different interest rates that you need to compare. One is saying, okay, we're going to give you 1%, one bank, let's say you have to invest your money. And one bank says, look, we will give you 1% only, but we will compound the interest rate 12 times a year. So there'll be 12 compounding of interest rates, only 1%. Another bank says, look, we'll give you 5%, but it's an annual interest rate. The third one gives you another option, 3%, but it's going to be compounded quarterly. So you have all these various options, and you need to figure out, which one is the best interest rate for you. And it's very hard to do that in your mind because, one is being compounded monthly, the other one is being compounded quarterly, and one is being compounded annually. So in order to do that, if you wanted to compare these 3 different interest rate scenarios, what you can do is to calculate the effective or equivalent annual rate. And in order to do that, there is a formula, and in this formula, it is basically brackets 1 plus the nominal interest rate divided by m, which is the number of periods of it's being compounded, number of times it's being compounded in a year, close brackets to the power of m, and you minus 1 from that. And so basically, like, for example, right over here, if there's an example given on the slide, if a bank would like to lend you money at a nominal rate of 12% compounded quarterly, then what is the effective or equivalent annual rate? And if you plug this into this formula, you will get 12.5509%. So that is the effective annual rate. So you are annualizing everything. You are saying that, you're basically bringing everything to one standard platform of an annual rate. So that way, then you can easily compare which of these 3 different scenarios, 3, options that the bank has offered you, which one is the best one. So in order to do that, you have to use the effective annual rate, and you have to annualize the interest rates. And again, the formula is quite simple, but you do need to be sure when to use it and why you're using it. Okay, so this slide also really talks a lot about what I just sort of mentioned. Here in this case, you see on the slide a situation where 12%, one bank is saying we will offer 12% annually. And so you know that the periodic interest rate and the effective interest rate is going to be 12%. And on the other hand, and you can also calculate the future value, which is going to be 112 based on this information. In the next couple of, if you go down, next couple of rows, you see that M is what is changing. So the number of times the interest rate is being compounded is changing. And what you see is that the higher the, if the nominal interest rate is the same and the number of periods or number of times the interest rate is being compounded is increasing, then what you notice is that the effective annual rate goes up, right? So if compounding is happening daily, that means 365 times there's going to be compounding of the interest rate. And that's going to be the best scenario because you're going to be getting the most amount of interest, if it's being compounded daily, right? As compared to if it's being compounded annually. And obviously this also has an impact on the future value of the money that you're putting in the bank. Or any, if you're investing in any financial security. So that impacts, the future value of your, of your basically of the income that you're going to be generating. And so, this really sort of shows you, how you can calculate the effective annual rate. And that way you'll be able to easily figure out which investment is better. And here you can easily see that, look, given the option that there's a nominal annual rate of 12%, and you would definitely pick the situation where there is daily compounding happening because that is giving you the highest rate of return. Okay, so far we assume that payments either occur at the beginning or the end of every period. So, we spoke about, annuity dues, about ordinary annuities, and we saw that in either payments were being, made at the beginning or at the end of the period. But we've never really spoken about a situation of if a payment is being made in the beginning of a period, in the middle of a period, sorry, or within periods. There are sometimes we do, however, face situations where compounding or discounting is happening over a fractional period, which basically means not at the beginning or not at the end, but somewhere in the middle. So let's look at how we would solve a question that involves, fractional time periods. Okay, so I'm going to give you an example and we're going to solve it together, and that will illustrate how to solve for fractional time periods. So suppose you deposited $100 in a bank that pays a nominal rate of 10% compounded daily based on the 365-day year. How much would you have after 9 months if using compounding interest rate? So here in this situation, the first thing we understand is that, look, this is not this 10% is not something that you're earning. The interest rate is not being compounded yearly. In fact, it is being compounded daily. So we have to first find the periodic rate of interest, and to calculate that, you're going to take the nominal interest rate of 10%, and you're going to divide it by 365, which is M. And that basically gives you 0.000273973 per day. Okay, that's how much, what the interest rate is, the periodic interest rate is. Now you want to, because you are now calculating per day how much interest you're making, you now want to calculate the number of days in 9 months. And so that you're going to be able to calculate by 9 over 12, which is because it's for 9 months rather than out of 12 months, so there's a year's out of, so if you had invested your money for a whole year, that would be different. But in this particular case, you're investing it just for 9 months. So therefore 9 divided by 12 multiplied by 365. And that gives you, we're talking about, about 270 3.75 days. If you round that up, it's going to be 274. So what is your end amount? How much money are you actually going to be making? Well, if you invest $100 in a situation where your money is being compounded daily at 10% for 9 months, you are going to be calculate that by taking 100, and you're going to say 1 plus I, the periodic rate, to the power of M, which is, in this case, it's going to be the number of days. So here it's going to be, yes, so it's going to be to the power of Mn. And so because in this particular situation, M is going to be 274, and N is basically multiplied by 1, because here we're just talking about, one period or 1 year. And so that's why N is 1. So that will give you a total of 107.79. So that is what your future value is going to be. So the formula is the same, but in this situation, the only difference is that you are dealing with fractional time periods. Now, if you were asked to calculate the simple interest rate in the same example, rather than the compounded interest rate, you would basically do that by saying 100 into 10% into 0.7506, which is basically 9 divided by 9 divided by 12, right? And if you wanted to be even more particular, that would be a 0.75. But if you want to be even more particular, as shown in this example, you're saying 274 days out of 365 days, and that's why it is 0.7506849. And you multiply this all together, and you would be getting 7.51. So again, here you are seeing a situation where you calculated the compounded interest rate for a fractional time period, and we've also just calculated the simple interest rate for fractional time period. Now, something else that's very important to familiarize ourselves with is something known as amortized loans. Okay, and amortized loans are basically loans that are paid off in installments over time. And so that's usually, let's say, take a loan for a big sum of money, and you tell the person who you've taken the loan from, look, I'll pay off every year a certain amount. And so that would be an example of an amortized loan, right? And another example is many times people take loans for houses. And so they've taken a big loan and they say, look, every month we will, pay in installments, we'll pay a little bit, a portion of that loan that we've taken. So we'll pay it off over a period of time. So let's look at a specific example of an amortized loan, and I am going to be showing you what it looks like on a timeline on the slide. So the example is, suppose a company borrows 100,000 with a loan to be repaid in 5 equal installments at the beginning of each of the next 5 years. The lender, so again, in this situation, a company has borrowed 100,000, and they're going to be repaying it and they're going to pay in equal installments at the end of each of the next 5 years. And the lender has charged 6% on the balance at the beginning of each year. So here's the picture. So obviously, if somebody is giving a loan, they do want to make some sort of income on that loan. So they charge a certain amount. In this case, they are charging 6%. Okay, well, if we put this on a timeline, we can see that, look, somebody has borrowed 100,000. So there is a cash inflow at that time. And here we're seeing that they have to make certain amount of payments at the end of every year for 5 years. And we know that the interest rate is 6%. One of the interesting questions is, how much payment do they need to make every year if the interest rate is 6% and they have borrowed 100,000 so that they are able to pay off this 100,000? So in order to calculate how the amount of payment that they need to make, this can be calculated using Excel. And in Excel, there is something known as the payment function. And so in the payment function, you basically say equal to payment, brackets, interest rate, comma, n, number of periods, comma, present value, comma, future value, and you close the brackets. In this example, if we were to calculate the payment, we know that the interest rate is 6%. So we would say, okay, equal to payment brackets 6% or 0.06, comma 5, comma 100,000, which is the present value because that is the amount of loan that they've taken, comma 0, and close brackets. And we would get negative 23,739.64. And what this basically means that the borrower has to make a payment of 23,739.64 per year for the next 5 years. Now, for amortized loans, many times people have to make a loan amortization schedule. At one time, I was working for an investment bank, and we started a scheme to give, car financing. So we, at that time, had to really calculate a lot of these amortized loan schedules. So this is an example of an amortized loan schedule. And here you can see that the principal amount is $100,000. Now, the first thing you need to calculate in an amortized loan schedule is the payment that you have to make every year. So we just saw how to calculate that payment using Excel and the payment function in Excel. So that amount of payment is going to stay constant. We know that every year you have to make that amount of a payment. Then next, you also need to calculate the interest amount that you need to pay. So you are going to be paying some sort of interest for borrowing the loan. And how you're going to calculate the interest is basically, we know that the interest rate in this situation is 6%. That's given right over here. And so in the first row, we are going to say, you always take the interest the interest rate is always going to stay the same. And you're always going to be taking the interest of the beginning amount or of the payment that you have to make, right? So the beginning amount in year one is 100,000. So 100,000 multiplied by 0.06 is 6,000. So in this situation, if we are going to be looking at how much of the repayment of the principal is happening, we are going to be saying that, look, it's going to be the payment, right? So the constant payment amount minus the interest rate that you are paying, okay? So you're actually effectively repaying 17,739.64 in the first year. And so your ending balance is going to be 100,000 minus this repayment of principal, or 17,739.64, and that is going to give you 82,260.36. This 82,260.36 is going to be the beginning amount then for year two. And so you know that the payment is going to stay the same. The interest rate now, if you have to calculate it, is going to actually be 0.06 multiplied by 82,260.36. And the repayment, as you know, is the payment minus the interest rate. You calculate that, and the ending balance is going to be the beginning amount. Again, the 82,260.36. And you are going to be subtracting the repayment of the principal from that, and that is going to give you 63,456.34. And you sort of go through it, and by the end, the test that your loan amortization schedule is correct is that by the end, your ending balance should be exact 0. So that is how you build an amortization loan schedule. And for this course, you do need to know how to calculate this. You will be tested on it. Now, in some situations or in some countries, the inflation rate is very high. And so what happens is investors want to know how much, let's say a bank is saying that you're going to be able to earn 23%, which is a huge amount. But let's say the interest rate is also very high. Well, in that case, investors may want to know what is their real or inflation adjusted interest rate, which is also known as the real rate. The way you calculate this is you say, 1 plus the nominal interest rate divided by 1 plus the inflation rate. And then you take all of this amount and you subtract 1 from it. And that will give you the exact, inflation adjusted real rate of return that you're making. If you wanted to calculate this in Excel, that can also be done. And basically you just, use this, but the formula is going to be pretty much the same. Now, let's say there is a situation where you are having to calculate, let's say, I'll just read out an example to you. And this example basically involves inflation, okay? And so this is because it involves inflation, we should realize that we will probably have to calculate the real rate as well, or the inflation adjusted interest rate to solve this question. So here in this question, I'm going to read out an example, the question, and then we will solve it together. Suppose you need to accumulate 100,000 in 10 years. You plan to make a deposit in a bank now at time 0, and then 9 more deposits at the beginning of each of the following 9 years for the total of 10 deposits. Okay. The bank pays 6% interest and you expect inflation to be 2% per year, and you plan to increase your annual deposits at the inflation rate. How much must you deposit initially? So in this situation, first you are going to calculate the real interest rate. So again, what's happening here is that you have in this question decided that, look, in 10 years time, you want to have a total of 100,000. Okay. And you have said that you want to make a deposit right now, you're at time 0. And then you're saying you also are ready to make 9 more deposits. So a total of 10 deposits. And you want that at the end of you, so you're going to make all these payments, but what you want to make sure is that, at the end of 10 years, you are going to have 100,000. And the question is saying that, look, you are told that the bank is offering 6% interest rate, but you're also being told that the inflation rate is 2% per year. So the question is asking you how much of a payment, what amount needs to be deposited every year for the next 10 years. So now, as soon as we see this, we've already learned in this lecture how to calculate payments. But the main thing that's different in this situation is that there is an inflation rate, right? So the first thing that to calculate the interest rate, right, we need to calculate the real rate. And we just saw in the previous slide how to calculate the real rate. So in this case, it's going to be 1.06 divided by 1.02, because 2% is the expected inflation rate. And we subtract that from 1, and that gives us 3.92%. So that is going to be the I that we are going to be using. Okay. And then next, because inflation is expected to be 2%, we now know that, look, actually we're not talking about having a total amount of 100,000 at the end of 10 years, because the value of that 100,000 in 10 years is not going to be 100,000, because there is inflation of 2% per year. The value of that 100,000 is actually going to be a lot less. It's actually going to be 100,000, and then you discount this at 2% 10 years. It's actually, we're talking about 82,000. And 82,034.83. So now we understand that, look, the target or the future value is not 100,000. We're actually talking about 82,034.83. So this is the future value we are going to put into a spreadsheet if we are using because here in order to calculate the payments, remember we have to use the payment function in Excel. So we would actually be using 82,034.83 as the future value. For the interest rate, we are not going to be using 6%. We are going to be using the real rate, which is going to be 0.0392. Okay, so we're going to input, and n is going to be 10 because there's no change in the number of periods, and present value is going to be 0 because we are figuring out, you know, what the payment is, and you know, we're not really talking about the present value. We're trying to figure out the future value, considering payments are being made every year. And if we input this into the formula in Excel, then we would get negative 6,598.87, which basically effectively means that 6,598.87 has to be invested every year for the next 10 years. And that way you would eventually end up earning 82,034.83, which is the same as 100,000 if you take into account 2% inflation rate per year. And that brings me to the end of today's lecture. I understand that it's a lot that we've covered and it's very overwhelming, but I will be making you do a lot of practice problems. We will be solving those practice problems together. And once you solve those problems, you will feel a lot more comfortable with these concepts. Thank you very much.